All right, in this video, we're going to be covering correlations. And if you've never heard of a correlation before, I'm going to give this basic definition here that a correlation is just a statistical relationship between two variables, and it's charted or plotted on a 2D axis with the X and Y axes. And so one note to make here is that correlation does not mean causation, but sometimes it can. It's going to be different depending on what two variables you're looking at. You know, every one is going to be different depending on what you're looking at. And so again, make this note that every correlational relationship is different. It's going to be up to you to decide why the correlational relationship is occurring, if there is one at all. So again, typically a correlation is going to be looking like this, where you're plotting points on an XY axis, and you're just going to be looking at, is there a relationship between these variables? And there actually is a statistical mathematical way to measure this, and it's called the correlational coefficient. So let's go over that real quick, that the correlational coefficient, what it essentially measures is how tight a correlation between two variables is, and it can be positive or negative, meaning the slope of the line you draw through it can be positive or negative slope, and it's going to follow this range here. So it can go from -1 to +1 with 0 being in the middle. So if you have a -1 correlational coefficient, that means it's a perfect negative correlation. If you have a +1, that means it's going to be a perfect positive correlation. And then a 0 would be that there's no correlation between the two variables whatsoever. And so any correlational coefficient is going to fall only in these ranges. You know, you can't go a -1.5 correlation or a 1.5. -1 is the lowest it can go, and 1 is the highest it can go, in any range in between those two. So let's take a look at some examples here, and this is going to be considered a perfect positive correlation because you notice all the points, you can draw a slope of a line directly through these points. So that means it's a perfect positive correlation. And again, these definitions of the correlations, you know, if you look this stuff up online, there's going to be different ranges that different resources will set for them. The exact name is not necessarily important, but to know what the numbers are is more important than what you call it. But a perfect positive correlation, you know, most places will have that range from 1 to 0.99. So, you know, essentially like the dots follow the line, or the plots on the point follow this slope, or the slope of a line, you know, almost 99 to 100%. They're very tight on that line. So it'd be perfect positive correlation. Let's look at a high positive correlation. And again, the range that I'm going to set for this one is going to be 0.98 to 0.8. So, you know, think about it's like 80% to 98% follows this line. So you can see that the dots, they're not right on that line like in the perfect positive correlation, but, you know, they're still pretty close. They're clearly all following in a direction. Then there's a moderate positive correlation, and this is going to have a correlational coefficient from 0.8 to 0.5. So again, it's not very tight to this line. You can definitely draw that line through these points, but you know, it's not tight. They're kind of far apart, but you can tell they're definitely still going in a direction. And then there's going to be a low positive correlation. And again, that's going to hold. I'm going to set the range for low positive from 0.5 to 0.2. And again, you can look up different resources and they might set a little bit different ranges, but just know the further the plot points get away from a line that you're drawing through it, the lower the correlation is going to be. And so see how you can see here, they still kind of look like they're going up in that positive slope, but not tight at all. They're very spread apart. So that's going to be a low positive correlation. And then there's this is going to be no correlation. And the coefficient would be from 0.2 to -0.2. So if you're getting this low, that means like there essentially is no correlation between these two variables here. So let's now flip it and let's look at the negative correlation. So again, this would be a perfect negative correlation, and it's going to hold a correlational coefficient of -1 to -0.99. And again, the only difference from this and the positive is that the slope of the line that you can draw through these points is going to be a negative slope versus a perfect positive. And then the points that you can draw a line through it, but it's going to be a positive slope line, not a negative slope. So this would be a high negative correlation, and the correlational coefficient range that I'm going to set for this is going to be 0.98 to negative 0.8. So again, you can see that the points are following this line. They're not quite as tight as a perfect negative correlation, but they are definitely still very tight, and you can draw a line through these points that they're all very close to. Again, the further you go, the closer you get towards 0, the less tight the points are going to get. So this is a moderate negative correlation, and it's going to be from negative 0.8 to negative 0.5 on the correlational coefficient. As you can see that the points are starting to get more apart. The relationship is not as tight between these, and then we'll move them even further apart to a low negative correlation from negative 0.5 to negative 0.2. You can see they're definitely still going kind of in a downward direction, but they're not very tight. They're not close to one another, but they are still kind of going in that negative direction. And then finally, again, from the 0.2 to negative 0.2 range, or if it's 0, anywhere in between those two is going to be pretty much no correlation. Again, it's very rare that you would do this and it's going to be actual 0. It's, even if it's not very much correlated, it's still going to give you a number. The number will just be a very small number like 0.1 or 0.2. So again, when you see that, you just know there's pretty much not any correlation between these two variables. So once you have your data copied and you're in Desmos, you're just going to paste it into this first row here. All right, so we're just going to paste our copied data and see now it plots the points out here. You know, we got our point 10 x 10, so a 10-year-old, 100 contacts, and then up to our last 40-year-old with 182 contacts in the phone. So what we're going to do now is we're going to learn how to find the correlational coefficient using this data. So you're going to be typing this formula here, and you have to do it exact. It's going to be y1, and then you're going to go, instead of equal sign, it's like you're going to do y equals mx plus b. You're going to change just a few things. So y1 approximation point mx1 plus b, and this is what you're going to type in to get these the stats that you need for these problems. So again, what it means is the y1 and the x1, it's like connecting it to the table, right? You got your x1, y1. A mistake that I've seen people made is that they'll post multiple data in multiple rows. So if you were to paste a second piece of data right below, like let's say I'm copying and pasting another table, it's going to be labeled x2 and y2. And so if you are typing in y1 and x1, it's going to still pull from your x1, y1. So again, like if I change this from x2, and this was y2, and I changed my y1 to y2 and this to mx2. So it doesn't matter if it's 1 or 2 or whatever the number is. It's just you have to make sure it's connecting to the correct table. But for sake of it, let's just go with our original x1 and y1. And again, we want to connect this to it. So we go y1 and x1, and boom. What that does is it draws the perfect line of best fit. It's called the line of best fit through these points. And the correlational coefficient is going to be this R number right here. So 0.9646. And again, so 1.0 would be the highest possible, a perfect positive correlation. So 0.9646, that's going to be a high positive correlation. That's, again, think about it as like a 96% correlation. And again, you can kind of, your eyes help tell the story too. You can tell that these points are very close to the line for the most part. So again, you know this is a high positive correlation based on that coefficient. Again, it's going to be this R number. And then here, the M, that just means the slope of this line is 2.7069. So again, like the formula, the line of best fit, the formula would be y equals 2.7069 0.297 plus 65.2978. So you don't need to worry about these. That's just what they mean. The number you want to focus on is R. That is going to be our correlational coefficient. So I'm going to do one more example, and this is going to be based off of the assignment. So again, if you're watching the video to the end, congratulations. You're going to get the first part of the first question done for you. But again, there's 12 total points, so this at most can get you 2 points. So you're going to be given 3 different scenarios, and you're going to do the same thing for each one. You're going to answer the same 3 questions. So in this one, it says the table is measuring the relationship between hours slept and student scores on their science test the next day. The data is from 10 students in Mr. Jones' first period science class. So first question you're going to answer is, what is the correlational coefficient for a point? Second is you're going to say what type of is it? So is it a high positive? Is it a low negative? Whatever. And then, do you think the 2 categories are related in any way? Is there a third-party variable connecting them? Or do you think the 2 are completely unrelated? And again, this one's worth 2 points because you're going to explain your reasoning on why or why not. Because even if 2 things are correlated, still that doesn't mean that they have much connection at all. Some of the things can be random. Again, just because they correlate doesn't mean that there's some perfect great relationship they have with one another. That's why your reasoning really is going to help you out with these ones. So what you're going to do is you're going to take the data. So we're just going to copy the data. So the number of hours slept is X variable and the score on the test is Y variable. So again, I think it's best to just delete everything and start over so you know you're correct connecting it to the right table. So we're just going to paste it, and you can see right there. So we're going to do the same thing. We're going to do Y1, and then we're going to put that approximation sign, X1, MX1 plus B, and now it draws the line of best fit through here. And so you can see that this is not as tight of a correlation as the previous example, but it's still definitely following a certain trajectory. And so you can see our correlational coefficient is 0.8657. So that is still in the ranges that I set, at least, as a high positive correlation. And again, the better way to think about it, I think, is think about it as like an 86% correlation for these points. So then you'd say for part 1, you'd say the correlational coefficient of 0.86. You can round to 2 decimal points if you want. And then you'd say this is a high positive correlation. And then you would say, I think that these 2 categories are related or unrelated. Again, I'm not going to mark you necessarily if I agree with you, but do you have good reasoning and why you think that? Again, it's the reasoning really is what matters on part 3.